Hello, my name is Bentley. This is assignment one for Introduction to Machine Learning. I'm going to kind of go through it fairly quickly. I don't want to waste too much time. I'm actually also going to run this all up. And let's see. Okay, so the main purpose of this one was using scikit-learn to denote whether or not which language it is. We're using three separate models, and we're going to test their accuracy. We should have MLP, KNN, and SVM as our models that we're using. Yeah, these ones here. And I have a little bit of instruction code before I actually go into my part when I'd written for reading the full text files and getting through everything, the processing, how I broke it up, just some basics. So starting out, we have a set of training data and target data. This is our labels. This is essentially, if you want to think about it as the score or the answers to the test. So the training data is the actual words themselves that we will be pulling from the text files. And in the instructions, the way that it's done is that it's kind of like vectorization we had went over a little bit whenever we were talking about reading each of the pixels and then converting them to like a legit number and then giving them weights. This is kind of the same thing. So we have these are our words, and then we are converting them using this function here. And well, we're iterating through them and we're putting them in a nested list. Well, you can see here because there's a double bracket here containing each one, and then each one is in a list of itself. So you see that 65, 78, 89, 79, 78, 69 is actually this word here. So, and that's going to be true as we go through. And I want to note too that they're all the same character size as well, because we're going to actually need to talk about that, and we're actually going to go into that a little bit. So, we have our training data, target data, we have a list iterated through, and then we're holding each of the values. We're importing the libraries using scikit-learn or sklearn. Um, So we import the models, we fit the data around the training and target. That's your always your first step. You have to fit it, and they have to be the same length. You can't have m more training than labeled because then you don't actually have the correct amount. You don't have the answer for each element in your training data. So this becomes our training data, and this becomes our predictions. It should be 0, 0, 0, 1, 1, 1. Of course, we're gonna have to check for accuracy because it might not always be accurate. So, we're gonna do a quick visualization with the accuracy. This isn't true, because these values are default values that we've just, or they're arbitrary. They're just given to them. But this is essentially what the visualization looks like here. I did change it in mine, and we'll look at that a little bit because I kind of prefer using Seaborn. I feel like just using Matplotlib is not as good. I just don't think it's as visually pleasing, and it doesn't give you enough for me personally. So I changed it a little bit, but same thing. So let's go into my code now and how we handled this problem. So I did use Google Drive to hold all the text documents. Cloud's a great way. Just you do it pretty quickly and efficiently. So I imported the Google Colab, mounted the drive, and then this right here basically lists all the text files. So we have English, German, and Spanish. So because the with this one we just have English and German, but we want to implement a new language, since we're using it's multi-classification, so whenever you're going over logistic regression, it's just a zero and a one. That's essentially what this one is. This is simply a logistic problem. There's only two classes available. It's either English or German, but now we're implementing it for a multi-class problem. So now we actually have three classes that we're actually dealing with. We have Spanish, German, and English. So this is kind of long, but I'm going to go through it fairly quickly. Um, so when I did, I had the file path, opened the file path, stripped it, put it into just raw where I had said it was a nested list, puts all of them into a nested list, and then just reads each one of those, stripped, add it, and then takes the length. So then I can count the length of the words that had come from the file. So that I know that I imported all of them because I can go back and check the text file to see the length of words in there. And then also just so the nested list, I wanted to print that too so that you can actually see what it looks like. We are supposed to only use 5 characters, which I probably could have written in here to only take 5 conditionally or take it if it has 5, but I wanted to break it down step by step. And I did the same thing for German and Spanish, so I'm not going to go over that. It's same thing. Let's see. Okay, so then we have to build our target data, our labels. Very, very simple actually. I didn't know about this at first, but you can essentially, I have my nested list here with my target for English. And this is really good, and this was part of the reason why I wanted to also get the word count. So then I just use the word count and I multiply it by however many zeros, and then it'll spread zeros out for the length of the words. So you can see that I have 194,433 words, and my target data, I also have to have each of my labels to have the same amount. So I have a zero for each one. And then, of course, we wanted to show the label, make sure that it's actually 194,000, not 433. We did that for all three. It was pretty simple. So now we need to convert our data, and we went over this. We're essentially, quite literally the same code. I actually copied and pasted it pretty much from the top tutorial part that I had shown, where we run the nested loop, and it takes each of the characters inside and converts them to a value or a weight with a number. So now each character in those words now actually becomes a weighted number value. And this was simple, kind of like df.head prints the first 5. So we could see what that looks like. Did it for all 3. Not going to go too much detail there, but that's essentially what I did. Okay, so you have to make all of the lists and the training data inside of have the same length, and they have to all be padded into a flat list. So that's essentially what this is doing. It's going through and flattening the list. And let me I had imported this library, and it helped with finding like the maximum length for the padding. Let me pull up here. So yeah, because the thing is that if we have the training, we can only have training data and target data, and we want that to be coherent with everything else, and we want it all like merged together. Could have probably just added all the lists. I thought flattening them to a one big list was the easiest way using this tool. So now let's essentially what happened here was we took all of our English characters here, and same for Spanish, or excuse me, same for German, same for Spanish. Flatten them all into one list. So now we have one big training data instead of three separate ones for each of the text files, and then we also did the same thing with the target data. So now we have the shape, which is essentially how many rows, how many columns are in our matrix. So 362,583. It does match the target data, 362,583. So since those are the same length, we can actually fit the model around it and do our predictions. However, I did I didn't read the instructions as well as I should have the first time I went through this. I definitely could have shortened this up a little bit because it has to be 5 characters because they all have to be the same character length. So that was one thing where I had struggled with following the directions as well as I could have. So I went back, Or, well, I didn't go back. I actually added new code that would help strip and only take it if it has 5 characters. And that's essentially what's happening here. Goes through the word list for each of the raw training data, and if the length of the word was 5, append it, and then same for labels. So now we have labels and training data that are only 5 characters long, and it essentially just shortened it up. So we took everything, shortened it down. So now we can actually look too, and we can see that. Yes, that's already changed. Yeah. So right here, we had broken it now down into each for having only 5 characters. Now we have 15,329 training and target data. So I was you could have splitted it manually. I found with Sklearn that they actually have a train test split, and you can actually import another, or I guess it already is imported, but you can add another parameter called random state. A really common one was 42 that I saw, and essentially that just makes sure that it's always having the same thing. I kind of wanted it to be different. I wanted it to change a little bit because I didn't want to always have the same accuracy. I wanted to go through a couple different iterations, kind of see what it looks like. So now that we've split our data into training data and test data, and if I haven't mentioned it, and I know that you already know, training and test data. Training is if we had only used just the training data and had it predict, then it would already have the answer, right? You have to split it up into, we did it a 70-30 split because it has to be split up into, or excuse me, not 70-30. Let me make sure. Uh, there's a split here. Oh, excuse me, 80% because and that is actually true. I was thinking of a different thing. Let me pull this down. Can't see it well. There we go. Yeah. Yeah, the test size is zero point 0.2, so 80/20. My apologies, and I also said it here. So we split the data, and because if you have the test data, um, or if you just use just the training data, then you are always going to have the right answer, right? Like, because you're going to see what the label is. So we're wanting to actually have it actually predict off something that it doesn't know, and then shoot and guess when it thinks that the date, when it thinks that it actually is with the prediction. So the rest is pretty self-explanatory. We're going to fit our data and transform it, and then we're going to make our predictions, and then we'll take an accuracy, and we're going to go over that. So imported each same exact code as before, really. We imported each of our machine learning libraries using sklearn. We fit the data around training and X train and Y train. And this is each of the models separately. So we use k nearest neighbors to make a prediction. Then we used SVM, support vector machine, which we went over in class pretty recently. Deals a lot with your soft margin, and we were running the widest margin as possible versus k-nearest neighbor, which is a classifier that only takes base off of the location and all of them together. Then we did multi-layer MLP, which we haven't gone over too far into yet, but I think we'll probably go over that one pretty soon. I also imported a library for accuracy score. There might have been a better way to go about doing it. I found that importing the library was the easiest way. Might as well just stick with sklearn since we're already using their machine learning libraries for making our predictions. So we did a predict with our X test and then we use the accuracy score, which takes 2 parameters, our Y, and then the actual accuracy for each one of our machine learning models, and then we printed it. Dot two is just rounds it up to the closest 2 point floating value. So then this is our accuracy scores for each one. So we have 85%, 87%, and 86%. So right here, it looks like SVM was actually our highest value, which is really great. It's pretty cool. So this is how I plotted it. I did it a little bit differently. I just made the subplot using the fig and axis, made my labels for each one. This is so I can get the correct percentage value. Rounded the values up so it didn't wasn't super long, kind of like the .2f for rounding up your floating points. And then just drew out the bar graph. And yeah, it's pretty self-explanatory. Um, and you can see, so this was our model's accuracy. So we have 85%, 86.5, and then 86.7, which is SVM, which in the whenever we printed the accuracy score, it rounded up. We can actually, because I was talking about random state 42, we actually should get different data each time. If we had stuck with that, then we wouldn't. But we can actually go here. We'll go ahead and fit around it again. Actually, let me make sure. Yeah, no, that's right. Okay, so we fit our data. We can make our predictions, which those will probably look mostly the same if that split will. So you see, this time we actually it was different. So 85%, 87, and 87%. So MLP actually had a higher accuracy score the second time we went through this. And we can actually plot that again. So you see now 80 actually MLP almost came up really close to where SVM was. And it looked like K Nearest Neighbors changed a little bit, but I don't remember what its last point was. So it might have done a little bit better, a little worse, but still 85%. So I think that's going to wrap it up. Thank you for watching. I really enjoyed this. This was a really great introduction into machine learning and really helped me grasp the concepts of training and testing data, some kind of a little bit into post or pre-processing for actually getting the models to fit around the data, transform them, and it was really cool to get to make these kinds of predictions. So yeah, this I think this will do. I really appreciate it, and I'll see y'all.